Okay, here's a little bit of a review from today. Today, we actually talked about two-way tables. We talked about Venn diagrams. So we're going to start with a two-way table, kind of walk through some of the examples of the stuff we learned today, and kind of tied to Venn diagrams. So I'm going to share screen. Okay, so here's our situation. A random sample of high school students were surveyed regarding their toilet paper habits. Should the toilet paper pull over the roll? Do they replace the roll when it's empty? The two-way table displays the data. Suppose we choose a member of a member of the sample at random. Define the events O, over, and R, replace. So on this one, this would be in terms of replaces a roll. This is my R, and no would be R complement. So it's saying not replace. This is preferring the toilet paper roll over. This is not O complement. So if we want to think about that, explain in plain language what POC means and find the probability. So what does POC mean? It means the probability a randomly selected high school student does not prefer the toilet paper to pull over the roll. Okay, and what it is basically, it's these people right here. And what we need to do is we need to figure out like our totals. So again, it's much like anytime we get a two-way table, we should put our totals in. 58 and 24, that gives me 82. 12 and 22, that gives me 34. When I add those together, I have 116 total. The preferred, this one down here, 58 and 12, is going to give me 70. 24 and 22 is going to give me 46. This is another total. And if you look, 70 and 46 also gives me 116. So in this case, the probability that someone doesn't prefer the toilet paper over the top is going to be our no's. In this case, the people who know are going to be 46. There are 46 total people out of 116. So again, these are all my no's out of the total amount. Explain why the probability of O or R doesn't equal probability of O plus the probability of R. Okay, well, let's take a look at that. Different colors. We can actually see this two different colors that make it stand out a little bit better. So in this case, the probability of O, the probability of over, that is going to be these people right here. That's my over. The probability of R, these are the probability of people who replace. So this is the probability of people who prefer it over or they replace. That's these people right here. And if you notice, we end up with an overlap. We end up with double counting the people who prefer it over and replace the roll when it's empty. So these people right here, really what these people are the O and R. That's who these people are, O and R. So the probability of O or R, which is also written as the probability of O union R, is equal to the probability of O. So in this case, the probability of O happening is going to be 70 out of 116 plus the probability of R. And we just figure R is going to be replaced, and those are going to be those 82 people out of 116. But what we need to do is we need to subtract the overlap, and that's going to be our and. That's these people, the double counts, minus 58 over 116. So 70 plus 82 gives me 152. 152 minus 58. 9. This is going to be equal to 94 out of 116. Don't turn it into a decimal. Don't reduce it. Just leave it alone. Okay. So that's like this is a rule. And just so you know, this rule is on your formula sheet. So what I'm saying is, if we look at our formula sheet, as I talked about in class, this is on the formula sheet. So you don't need to memorize it. You just need to know where to find it. Okay. Next thing, we need to find a Venn diagram. We need to turn this into a Venn diagram. So the way this is going to work in a Venn diagram, we got our big old box, that is everybody. So we'll make these our replace the role people. We'll make these, I should have made the surface a little bigger. Make these our over the top people. So we start here in the middle. In this case, this is going to be the people who, in the middle here, are the people who prefer the toilet paper over the top and replace the roll. So it's these 58 people. These people here are the people who prefer it over the top, but don't replace the roll. They're not in that red circle. That's these 12. These are the people who replace the roll, but don't prefer it over the top. It's these 24. And then outside in this box out here, these are the people who neither replace the roll nor prefer it over the top. It's the people we didn't include, those 22. So that would be my sample space in that one. Or you could have done it with the probabilities as well. Either one would have been fine. So if I had done that with probabilities, ready? Again, O, so R and O. So this would have been 58 out of 116. This would have been 24 out of 116. This would have been 12 out of 116. And this would have been 22 out of 116. Again, either one's fine. This one's kind of easier to see. This one is just putting it in the probability terms. Last one, right? The event does not replace the roll and prefers the toilet paper pulls over the roll. Okay, so this one says does not replace the roll. So in this case, it's these people up here, my RC. They do not replace the roll and, so we got an and, that's the intersect, prefers the toilet paper over the top. So that is O. So again, these people here don't replace the roll. These people here are the ones who prefer it over the top. So in this case, this is an and. It's asking me for that number right there. And it's usually going to ask you for one of the boxes. So this one's going to be 12 out of 116. So that's a little summary of this. We're going to work on this in class today. I have some other practices that we're going to work on as well, and I'll make a little separate video that'll kind of explain some of those answers. So hopefully that helps a little bit. We're getting into this part where really you need to practice. You need to do these problems so you kind of get the rhythm of them. So please ask questions, use a reflection for that.